Okay, so we're still in 5.4, we're doing radicals. So here we have perfect square numbers, and they're just a group of numbers that are nice. And how do we get these perfect square numbers? We just square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. Or you can think of it, if we take the square root of these numbers, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the square root of 9 is 3, the square root of 16 is 4. So these are just a group of special numbers that when you square our whole numbers, or sorry, when you square our positive integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it keeps going, see the dot, 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 it keeps going. They're just called perfect square numbers. And you kind of have to know them because it helps you in this book. And in math, it'll help you. Okay? This sign like this is called the radical symbol. And we also call it the square root because when we have it looking like this, really, there's a 2 here. Okay, and the 2, we use this one so much that we're kind of lazy, we don't write the 2. So this and this are the same. We can also have a 3 here, like a cubed root, the 4th root, 5th root, 6th root. We have lots of them, and we use the radical sign, but we don't use these for this book. This one is called the square root, because remember how we can have, let's do 5. 5 to the power of 2, that's 5 squared, maraba, square. If we have 5 to the 3, then it's a cube, makab, 5 cubed. So if there's a 2 here, it's the same. It's, oops, you don't see the square. 5 to the power of 2 is a square. So this is square root. If you have a 3 there, it's like a cube, 3D. This is 3D, this is 2D. So the 3 is called cube. So this one would be called cubed root. This would be the 4th root, the 5th root. Okay, so this one is called the square root because we're using a 2 here. If we had a 3, it'd be cubed root. So in this book, we're just doing the square root. Okay? So the number that's underneath the radical symbol is called the radicand. So I say, what is the radicand here? 81. The answer to this is 9, and we can call that the solution or the root or the answer. This little number up here, hiding, is called the root index. Okay. If there's a number in front of your radical sign, it's called a coefficient. And it just means the number in front of the radical sign. But you can also have, say I have 2x cubed. The number in front of the x cubed is also called the coefficient. So it's just a number in front. You might hear me say coefficient sometimes. Okay? So the principal square root. So we can have a square root with nothing in front, a subtract in front, or a negative, or a positive and the negative in front. And if there's nothing in front, it's asking for the positive answer. If there's a negative in front, it's looking for the negative answer. And if it's a plus and it's minus, it wants both answers. So the positive one, we say the principal square root. Now the word principal is like, you know when you have the head of the school, like you have the big boss of the school? Well, that's the principal or the director. So it kind of means like the main thing, the main one, the most important. So the most important square root is the positive one. So when we don't write positive in front when we want the positive one. So if we look, if I take the square root of 25, the answer can be positive 5 or negative 5 because 5 squared is 25. But negative 5 squared is also 25, okay? But we don't want both answers all the time. So here, if there's nothing in front, you take the principal or the main or the most important square root, which is the positive. If there's a negative, take the negative one, and if it's both, take both. So let's see. Nothing in front, so square root of 16 is positive 4. If I put positive and negative, it means they want both of them. So I want negative 10 and 10. You can write it this way, or you can put plus and minus in front. Here, it says it wants the negative root, so you can go like this. So the square root of 64 is 8, but we want the negative 8. And here, 5 times 5 is 25, but there's nothing in front, so we want the principal square root, which is positive 5. So the square root of 69, it's wrong, because I wrote it wrong in my computer, so it should be 169. And the square root of 169 is 13. Okay, and because there's nothing in front, it means I want the positive one. So what times what is 121? 11. But it says we want the positive and the negative, so I can write it like this, or I can write it like this. I can write both of them, or I can write it together. 5 times 5 is 25. So the square root of 25 is 5, but it says we want the negative root. 9 times 9 is 81. And there's nothing in front, so we want the principal square root, which is positive. 2 times 2 is 4, and we want both roots, plus and minus. So I can write it that way, or I can write minus 2 and 2. Same. 3 times 3 is 9, but there's nothing in front, so we want the principal square root, which is positive 3. 4 times 4 is 16, but we want the negative root. 6 times 6 is 36, but it says we want the negative root. Okay. Write out the first 12 perfect square numbers starting with 1. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 5 times 5 is 25, 6 times 6, or 6 squared, 36. What's next? Yeah, 7 times 7 is 49. 8 times 8 is 64. 9 squared, 81. So I can say 9 squared, or I can say 9 times 9. It means the same thing. 10 squared, 100. 11 squared, what's 11 squared? 11 times 11 is 121. And then 12 squared is 12 times 12, 144. Okay, so now it says, what is the missing perfect square? So we have 4, then we have 16, then we have 25. So the one that's missing is here, which is 9. I have 16, I have 25, then I have nothing, and then 49. So it's the 36 that's missing. 64, 81, the next one is 100. What's after 121? 144. So you have to know your perfect squares. It makes it easier. Okay?